Hi everyone, welcome this chapter, transportation of data. In the first point is role of the transportation layer. Wait a moment please. Okay, application layer programs generate data that must be exchanged between source and destination host. The transport layer is responsible for logical communication between applications running on different hosts. This may include services such as establishing a temporary session between two hosts and the reliable transmission of information for an application. As shown in the figure, the transport layer is the link between the application layer and the lower layers that are responsible for network transmission. And in this image, we can see the stack of OSI model. In the first step is network access, the next is internet, the next is transport, and the last is application. The transport layer moves data between application and devices in the network. Uh, the transport layer has no knowledge of the destination host type, the type of media over which the data must travel, the path taken by the data, the congestion on a link, or the size of the network. The transport layer includes two protocols: Transmission Control Protocol (TCP) and User Datagram Protocol (UDP). Layer responsibilities. Transport layer has many responsibilities. Select each tab for more information. In the first tab is tracking individual conversation. At the transport layer, each set of data flowing between a source application and a destination application is known as a conversation and is tracked separately. It's the responsibility of the transport layer to maintain and track these multiple conversations. As illustrated in the figure, a host may have multiple applications that are communicating across the network simultaneously. Most networks have a limitation on the amount of data that can be included in a single packet. Therefore, data must be divided into manageable pieces. The next step is segmenting data and resembling segments. It's the transport layer responsibility to divide the application data into appropriate sized blocks. Depending on the transport layer protocol used, the transport layer blocks are called either segments or datagrams. The figure illustrates the transport layer using different blocks for each conversation. The transport layer divides the data into small blocks, segments or datagrams that are easy to manage and transport. Okay. The next tab is Add Header Information. The Transport Layer Protocol also adds header information containing binary data organized into several fields to each block of data. It's the values in these fields that enable various transport layer protocols to perform different functions in managing data communication. For instance, the header information is used by the receiving host to reassemble the blocks of data into a complete data stream from the receiving application layer program. The transport layer ensures that even with multiple applications running on a device, all applications receive the correct data. Okay, the next tab is identify the application. The transport layer must be able to separate and manage multiple communications with different transport requirements needed to pass data stream to the proper application. The transport layer identifies the target application using an identifier called a port number. As illustrated in the figure, each software process that needs to access the network is assign a port number unique to the host. In this example, different application, in this case, electronic mail port 110, port 80 is for the HTML page, and the port 531 is internet chat. And the last tab is conversation multiplexing, sending some types of data, streaming video across a network as one complete communication stream can consume all the available bandwidth. This will prevent other communication conversations from occurring at the same time. It will also make error recovery and retransmission of damaged data difficult. As shown in the figure, the transport layer uses segmentation and multiplexing to enable different communication conversations to be interleaved on the same network. Error checking can be performed on the data in the segment to determine if the segment was altered during the transmission. And segmentation allows conversation multiplexing. Multiple applications can use the network at the same time. Segmentation facilitates data transport by the lower network layers. The next point is transport layer protocols. IP is concerned only with the structure, addressing, and routing of packets. IP does not specify how the delivery or transport of the packet takes place. Transport layer protocol specifies how the transfer messages between hosts and are responsible for manage reliability requirements of a conversation. The transport layer includes the TCP and UDP protocols. Different applications have different transport reliability requirements. Therefore, TCP/IP provides two transport layer protocols as shown in the figure. This is the layer of application and this is the layer of transport. Transmission Control Protocol (TCP) IP is concerned only with the structure, addressing, and routing of packets from original sender to final destination. IP is not responsible for guaranteed delivery or determine whether a connection between the sender and receiver needs to be established. TCP is considered a reliable, full-featured transport layer protocol, which ensures that all of the data arrives at the destination. TCP includes fields which ensure the delivery of the application data. These fields require additional processing by the sending and receiving hosts. Note: TCP divides data into segments. TCP transport is analogous to sending packets that are tracked from source to destination. If a shipping order is broken up into several packets, a customer can check only to see the order of the delivery. TCP provides reliability and flow control using this basic operation. Number and track data segment transmitted to a specific host from a specific application. Acknowledge received data. Retransmit any acknowledged data after a certain amount of time. Sequence data that might arrive in wrong order and send data at an efficient rate that is acceptable by the receiver. In order to maintain the state of a conversation and track the information, TCP must first establish a connection between the sender and the receiving. This is why TCP is known as a connection-oriented protocol. Let's play in the figure to see how TCP segment and acknowledgement are transmitted between sender and receiving. Okay. The next point is User Datagram Protocol (UDP). UDP is a simple transport layer protocol that TCP. It does not provide reliability and flow control, which means it requires few header fields. Because the sender and the receiver UDP process do not have to manage reliability and flow control. This means UDP datagrams can be processed faster than TCP segments. UDP provides the basic functions for delivering datagrams between the appropriate application with very little overhead and the data checking. Note: UDP divides data into datagrams that are also referred to as segments. UDP is a connectionless protocol because UDP does not provide reliability or flow control. It does not require an established connection because UDP does not track information sent or received between the client and server. UDP is also known as a stateless protocol. UDP is also known as a best effort delivery protocol because there is no acknowledgement that the data is received at the destination. With UDP, there are no transport layer processes that inform the sender of a successful delivery. UDP is like placing a regular, non-registered letter in the mail. The sender of the letter is not aware of the ability of the availability of the receiver to receive the letter, nor is the post office responsible for tracking the letter or informing the sender if the letter does not arrive at the destination final. Okay. A file is sent to a server using the Trivial File Transfer Protocol (TFTP) application. UDP divides the data into datagrams and send them using best effort delivery. The file server receives all 6 segments. No acknowledgement is sent. The right transport layer protocol for the right application. Some applications can tolerate some data loss during transmission over the network, but delays in transmission are unacceptable. For this application, UDP is the better choice because it requires less network overhead. UDP is preferable for applications such as voice over IP, VoIP, acknowledgement and retransmission will slow down delivery and make the voice conversation unacceptable. UDP is also used by request and replay applications where the data is minimal and retransmission can be done quickly. For example, domain name system (DNS) use UDP for this type of transaction. The client requests IP for an IPv6 address for a known domain name from a DNS server. If the client does not receive a response in a predetermined amount of time, it simply sends the request again. For example, if one or two segments or a live video stream fail to arrive, it creates a momentary disruption in the stream. This may appear as distortion in the image or sound, but may not be noticeable to the user. If the destination device had to account for lost data, the stream could be delayed while waiting for retransmission, therefore causing the image or sound to be greatly degraded. In this case, it's better to render the best media possible with the segment received and forego reliability. For other applications, it's important that all the data arrives and that it can be processed in the proper sequence. For these types of application, TCP is used as a transport protocol. For example, applications such as database, web browsers, and email clients require that all data that is sent arrives at the destination in its original conditions. Any missing data could corrupt communication, making it either incomplete or unreadable. For example, it's important when accessing breaking banking or bank information over the web to make sure all the information is sent and received correctly. Application developers must choose which transport protocol type is appropriate based on the requirements of the application. Video may be sent over TCP or UDP. Applications that stream store audio and video typically use TCP. The application uses TCP to perform buffering, bandwidth probing, and congestion control in order to better control the user experience. Real-time video and voice usually use UDP, but many also use TCP or both UDP and TCP. A video conferencing application may use UDP by default, but because many firewalls block UDP, the application can also be sent over TCP. Applications that stream store audio and video use TCP. For example, if your network suddenly cannot support the bandwidth needed to watch an on-demand movie, the application pauses the playback. During the pause, you might see a buffering message while TCP works to re-establish the streaming. When all the segments are in order and a minimum level of bandwidth is restored, your TCP session resumes and the movie resumes playing. The figure summarizes difference between UDP and TCP. Okay, this is UDP. Required protocol properties: fast, low overhead, does not require acknowledgement, does not resend lost data, and deliver data as it arrives. In the case of TCP, required protocol properties is reliable, acknowledge data, resend lost data, and deliver data in sequence order. This is an example of UDP and VoIP, IP telephony, and this is an example for TCP, HTTP or HTTPS, World Wide Web. Okay, finish with check your understanding transportation of data. Question 1. Which layer is responsible for establishing a temporality communication session between the source and destination host application? This is the transport layer. That's right. The transport layer is responsible for establishing a temporary communication session between the source and destination host application. Which three are transport layer responsibilities? Choose three. Okay, conversation multiplexing, segmenting data and reassembling segments, tracking individual conversation. The transport layer is responsible for conversation multiplexing, segmenting data and reassembling segments and tracking individual conversation. Which transport layer protocol statement is true? UDP is a best effort delivery protocol. Okay. Which transport layer protocol will be used for both IP application? User Datagram protocol. And this is all for this. See you in the next one. Bye.